students, today's agenda is to check homework. We'll be working on arithmetic sequences and you will be able to do 5.5. Today, students will be able to create an explicit formulae for arithmetic sequences. And formulae is just the plural of formula. We're going to start with a definition of what arithmetic sequences are. And so arithmetic sequence, a sequence of numbers that increases by a constant amount. That means that and actually you should also say decreases. So you keep adding the same amount or you keep subtracting the same amount. Okay, having that in mind, let's begin with the first one. And so in here, we have a sequence of numbers. And it says 4, 7, 10, 13, and 16. And so we can see that the initial point is 4. So initial point. Okay. And we can see also that something's going on. From this number to this number, what are we doing? If it was 4 and now it's 7, well, we're adding 3. And then from 7 to 10, oh, we added another 3. From 10 to 13, oh, so it's a pattern because we're doing the same thing, okay? This is called the pattern. And so for the explicit formula, if you recall from last year, actually, what this means is that the explicit formula is to go directly to a number. There is a formula that you have to look at the previous one, but in here, the explicit formula, you can go to any number, skipping others. So the explicit formula is always f of n equals the initial point, which is 4. Okay, so we always start by putting the initial point. And we do the pattern. So in here we're going to be putting plus 3, and since it's arithmetic, if you remember, we're going to put n minus 1 as a factor. N minus 1. Okay, n minus 1 always goes with the pattern. Very important, always with the pattern. So that's it if you don't want to simplify it, but you can also simplify the formula. So this is a possible answer. The other one is to actually do distributive property. And so this is going to be equal to, we keep the 4. We multiply in here, 3 times n is 3n. 3 times negative 1 is negative 3. We combine like terms, so negative 3 and positive 4. And so f of n is equals to 3n plus 1. Because we have a positive 4 and we owe 3, that means we have positive 1. Okay, so it might be like this, that's not simplified, or you might give the answer simplified by doing distributive property and combining like terms. Okay, so either one of these is fine with me. Some teachers will tell you to go all the way here. For me, either one will be perfectly fine. Okay, we have another one here. And so you have 5. That's my initial point. And so the initial point is always the first number in the list, in the sequence. Okay, so what is going on in here? Well, from 5 to 7, you're adding 2, but then you have to check the rest to see if that's what's happening. Plus 2 is 9, plus 2 is, yes, that's the pattern. Adding 2, adding 2, adding 2. So again, my explicit formula is f of n, all the time f of n is equals to the initial point, I don't know if I should write it, that doesn't look very clear. So the initial point, okay, the first number, then the pattern, you're adding 2. So let me circle. This is the initial point. Then the pattern, you're adding 2. And if you're if you're adding or subtracting, n minus 1 will be always a factor. So tomorrow or the next lesson, you will see why I say that you need to do it as a factor. Okay, you might recall from last year. Okay, again, this is the answer if you don't simplify. But if you need to simplify, then do distributive property, and that's going to be equals to 5. 2 times n is 2n. 2 times -1 is -2. Combine like terms. In this case, only the constants can be combined. And so you get 2n, positive 5, -2. That's equals to 3. Remember that when the signs are different, we subtract. 5 minus 2 is 3, and keep the sign of the greater one. In this case, it's positive. So this is the other way of writing it if you need to simplify. Okay, let's do one more. And so you have the initial point is 11. What's going on in the pattern? What's going on? So you're subtracting 3, subtracting 3, subtracting 3. If you have 2 minus 3, well, you subtract and leave the sign of the greater one. So that's why you have -1. Okay, so subtracting 3. Again, it's going to be f of n equals initial point, pattern, n minus 1. Okay, that's the answer. Initial point, the pattern, and then the pattern is being multiplied by n minus 1. Distributive property, remember that this can be the answer, but if you want to simplify or your teacher or professor asks you to simplify, then you need to do this next step. 11, -3 times n is -3n. -3 times -1 is +3. We combine like terms, and so this is equals to -3n. 11 plus 3 is 14. So this is the formula, the explicit formula being simplified. Okay, let's do another one. And so you have -2, -1, 0, 1, 2. And so this is a little confusing because you have negative numbers and positive numbers. When you have something like that, analyze first the positive part and see what's going on. We already know that the initial point is just the first one, right? Initial point. And the pattern, even though it should be the same, it must be the same, we have to look at what's going on. From 0 to 1, oh, it's 1 more. From 1 to 2, oh, 1 more. So it's +1, +1. In here, is it +1? A lot of people get confused. Oh, it's a 2 and then a 1. They're negatives. And people say, oh, no, it's subtracting 1. But no, look, you owe $2. And now you owe $1. That means that you had to pay $1 for that to make sense, right? So you're still adding 1. You owe $1 and then you will owe 0. That means that you paid $1. So it is, the pattern is +1, +1. Okay, so my formula is going to be f of n equals initial point, which is -2, pattern, which is +1, And the pattern is always multiply by n minus 1 when it's addition or subtraction. That's the answer. If they're asking you to just leave it like that. But if we simplify it, we get negative 2. And when you multiply 1 times n is n. 1 times negative 1 is negative 1. Combine like terms. And you get equals to n. Negative 2, negative 1, you owe $2. You owe $1. You owe a total of $3. Okay, so it's f of n equals n minus 3. Okay, so that's when you're given a sequence of numbers and you're asked to look for the explicit formula, either simplified or not simplified. But sometimes what they give you is the formula and you have to get the sequence. To do that, it's like saying look for the first one, look for the second number, look for the third number, look for the fourth number, for the fifth number. Okay, have that in mind. 1, 2, 3, 4, 5. So in here, what we're gonna do is basically to look for the first one, we're gonna replace n by 1. So let's start doing it. I'm gonna leave a space in here to write the sequence. I'm gonna start by putting f of 1 equals 5 times 1 plus 3. All I did was to replace the 1 in here. 5 times 1 is 5 plus 3, that's equals to 8. So the first number is 8. Or you can just put f of 1. Okay. For the second number, I'm going to write f of 2 is equal to 5 times 2 plus 3. And this gives me 10 plus 3 equals 13. For the third number, I'm going to put f of 3 is equals to 5 times 3 plus 3. That's 3 times 5 is 15 plus 3 gives me 18. So the third number is 18. The fourth iteration is f of 4 is equal to 5 times the value of that n, which is 4, plus 3. 5 times 4 is 20, plus 3 gives me 23. And you can continue, or you can just say, okay, what am I doing? This is my initial point, because that's the first number I got. But then, what did I do to get 13? Oh, I'm adding 5. I'm adding 5. I'm adding 5. So in here, 23 plus 5 is going to be 28. The sixth iteration is going to be 28 plus 5 is 33. Okay? And so that's how you can figure out, even with the first 3, I think you will be able to figure out the rest. Okay, let's do another example. So in here, again, I'm going to leave some space in here to put my sequence. So basically, this is the answer. This is my sequence. My arithmetic sequence, because I'm adding or subtracting. Okay, so again, I'm going to start with f of 1 to find my initial point. And it's going to be negative 2 times 1 plus 5. Negative 2 times 1 is negative 2 plus 5. And that's 3. So my initial point is 3. Remember that if you have different signs, you subtract and leave the sign of the greater one. F of 2 is equals to negative 2 times 2 plus 5. And negative 2 times 2 is negative 4 plus 5, which gives me, I owe $4, I pay with 5, that means I have 1. What's going on? It looks like we are subtracting 1. We'll see. F of 3 equals negative 2 times, replace the n with that number. So it's 3 plus 5, and it's negative 2 times 3 is negative 6 plus 5. Negative 6 and positive 5 is negative 1. So am I subtracting 2? Minus 2 equals 1. If I only have $1 and they take away 2, that means that I am in debt. I owe $1. So I'm going to subtract another 2, and that means I am going to owe $3 instead of 1. I'm going to owe $5 instead of 1. If you're not sure, especially with the negatives, you can continue to do this work. Okay? Maybe like f of 4 equals negative 2 times the value of 4 plus 5. And so negative 2 times 4 is negative 8 plus 5. In here, I owe $8 but have $5. I pay with those 5, and now I owe only 3. So see, negative 3 for the fourth one. 1, 2, 3, 4. That's where it is. And another 1, 2, 3, 4, 5. Now I need one more. Minus 7. Okay? And so on. So this is my arithmetic sequence, and I'm actually subtracting 2. Okay, so let's see if I can do the last 2, because it seems that I'm running out of battery. Okay, I'm gonna leave space for my sequence. I'm gonna do f of 1. In here, let me tell you, and I think if you recall, when we have the n minus 1, even looking at the non-simplified, this is my initial point, and this is the pattern. So looking at the first examples, anytime you have already n minus 1 in there, that means that this is my pattern, if you recall. So this is the pattern, and this is my initial point. And I'm gonna show you how to do this without having to do this work, but I'm also gonna do it. So the initial point is 4, and after that we add every single time. So 4 plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12, plus 2, 14. Now let me show you that it does work. So f of 1 is equals to 4 plus 2 times n is 1, minus 1, okay, and the value of n is replaced by 1, minus 1, okay. We simplify this, and so we get 4 plus 2, 1 minus 1 is 0, and then 4 plus 2 times 0 is 0, and 4 plus 0 is 4. So notice how the initial point is 4, which is the right answer here. I do f of 2 is equals to, again, 4 plus 2. I replace the n by the value inside this parenthesis, so it's 2 minus 1. 4 plus 2. We simplify inside of the parenthesis, and 2 minus 1 is 1. Then according to PEMDAS, I have to multiply first and then add. So keep the 4 plus the multiplication of 2 times 1 is 2, and the answer is 6. See, that's for the second one. Now f of 3 is equals to 4 plus 2 times 3 minus 1. Simplify this part first, so it's 4 plus 2. Simplify 3 minus 1 is 2. Remember that we multiply before we add, so it's going to be 4 plus 4, and the answer is 8. And you can see that you're adding 2, so you keep adding 2 in all of them. That's again if you can see that this is the initial point and you're adding 2 each time. One last one. Hopefully I don't run out of battery, but if I do, just make sure you do 5.5. Okay, so I'm gonna leave space for my sequence in there, and so f of 1 is equals to 21 minus 7, and I just replace the 1 in there. So 21 minus 7 times 1 minus 1. So 21 minus 7, 1 minus 1 is 0. And so I have 21. Negative 7 times 0 is 0, so minus 0. And 21 minus 0 is just 21. So, oh, I forgot that we could, remember, we have the initial point and you're subtracting. Anytime you have the n minus 1, this is the initial point. Whatever is being multiplied by n minus 1 is the pattern. So what are we going to be doing? Subtracting 7, minus 7, minus 7, minus 7. Okay? But, so the next one should be 14, because if you subtract 7, that should be 14. We'll see. F of 2 is equals to 21 minus 7 times n. The value of n is 2 minus 1. We don't subtract this first. Remember that we have to do parentheses first and then the multiplication. So minus 7. 2 minus 1 is 1. 21. Negative 7 times 1, negative 7. And 21 take away 7, that's 14. F of 3 equals to 21 minus 7 times 3 minus 1. Simplify parentheses first, the rest stays the same. And inside of the parentheses we get 3 minus 1 is 2. And so we do the multiplication before the subtraction, okay? So it's going to be 21. Negative 7 times 2 is negative 14. And 21 minus 14, you get 7. Guess what the other one will be? It's going to be 0. Okay, so minus 7, minus 7, minus 7. I think I want to do one up to maybe number 5. I'll do up to 5 if I have. So f of 4 is going to be 21 minus 7 times 4 minus 1 equals 21 minus 7 times 4 minus 1 is 3. 21 minus 7 times 3 is 21. And 21 take away 21 is 0. See that one? I want to do the next one just because we're going to get a negative. Although you might say, oh, 0 minus 7 is negative 7. But I want you to look at this. So 21 minus 7 times n is 5 minus 1. And 21 minus 7, simplify this first. 5 minus 1, 4. 21 minus 7 times 4 is 28. And in here, it's like having a positive and a negative. This minus becomes the sign of the 28. So, or you're subtracting a bigger number than this smaller number. So it's going to be 28 minus 21 is 7. And leave the greater sign, which is negative. So the next one is going to be negative 7. And after that, it's going to be minus 7 will be negative 14, etc. Okay, so now you're able to do 5.5 and have fun.